Okay, Pascal's triangle is it's a special triangle that this guy named Pascal came up with of how to know what number, what coefficient is going to be multiplied by your variables before you expand it. So what that means is there's a triangle and it kind of is broken down like this. If I have something like a and b to the power of 0, anything to the power of 0 equals 1. So that equals 1. If I have a plus b to the power of 1, that means it's just itself. So the coefficients, the numbers in front, are just going to be 1 and 1. So 1 and 1. If I have a plus b squared, when I expand this, I'm going to get a squared plus 2ab plus b squared, which means that I'm going to have coefficients of 1, 2, and 1. Now there's a pattern that happens here. So for the first ones, you can't really see the pattern, but now the outside is always 1. The inside is the two numbers that touch it added together. So I'm going to have, if I go to the next step, a plus b to the power of 3, the outside numbers are going to be 1. The inside numbers are going to be these added together, which is 3, and these added together, which is 3. If I go to the next step, a plus b to the power of 4, the outside numbers are still going to be 1. This is going to be 4, 6, and 4. And it just continues like that. So what does that mean? That means that if I had x plus 3 to the power of 4, I know that my solution is going to be coefficients of 1, 4, 6, 4, and 1. Because this is a plus, they're all pluses. But these are multiplied times something. So what they get multiplied by is your a value to the same power that you started with, and then decreasing by 1 every single time. Your b value to the power of 0, and then increasing by 1 every single time. So what this is going to be multiplied by, and I actually didn't leave myself enough room, so I'm going to spread it out a little bit. What this is going to be multiplied by is my a value to the power that we started with, and my b value to the power of 0. This is going to go down 1. This is going to go up 1. This is going to go down 1. This is going to go up 1. This is going to go down 1. This is going to go up 1. And this is going to go down 1. And this is going to go up 1. I'm kind of getting compressed on room, so I'll do another example definitely for sure so that you can see. So what happens here is 3 to the power of 0. Anything to the power of 0 is 1 times 1 is still 1 times x to the 4 is x to the 4. 3 to the power of 0 is 3 times 4 is 12 x to the third. 3 to the power of 2 is 9 times 6 is 54 x squared. 3 to the power of 3 is 27 times 4 is 108 x. And then 3 to the power of 4 is going to be 81 times 1 is still 81, and x to the 0 is also 1, so times 1 again is still 81. So this is your final answer, and that's doing it without doing the expansion. Okay, the other way that you could do this, and it is kind of hard, is you would expand it out. X plus 3 to the power of 4 is the same thing as x plus 3 times x plus 3 times x plus 3 times x plus 3. So I'd have to expand this, and then multiply it, expand it with this, and then multiply and expand it with this, which is going to take me a long time, and it's going to give me the same answer. So let me try to show you another example. I'm actually going to turn the paper sideways so it's a little bit better. So I'm going to use one out of the book, which they have 4z plus 5 to the power of 3. Well, if I remember on my triangle right here, 3 is going to be 1, 3, 3, 1. So 1, 3, 3, 1. You always want to put plus signs in here, and I'll show you what happens when you have a negative value up here, okay? I'll do another example that shows that. So your first term to the power you started with times your last term to the power of 0. This one goes down 1, and this one goes up 1. This one goes down 1, and this one goes up 1. This one goes down 1, and this one goes up 1. Okay? Now I'm going to multiply this out. 5 to the power of 0 is 1, times 1 is 1. 4z to the power of 3 is really 4 to the power of 3 and z to the power of 3. So 4 to the power of 3 is 64. Z to the third plus 5 to the power of 1 is 5 times 3 is 15. 4z squared is really 4 squared and z squared. So 4 squared is 16 times 15 is 240. 5 squared is 25 times 3 is 75. 4z to the 1 is just going to give me 4z. So 75 times 4z is going to give me 300z. Okay, that's a car. That's hilarious. It's not really. 5 to the third is 125. 4z to the 0 is 1. So 125 times 1 is still 125. Times 1 is still 125. And that's your final answer. Okay? Now I'm going to do one where it's negative. And I'm going to use this same paper. So I'm just going to use the top. So I'm just going to change the sign inside of here. Well, I forgot to do it. I'm still going to set it up the same way. So it's still going to be 1 plus 3 plus 3 plus 1. But we'll see what happens when I have a negative. So my first term to the power I started with, my last term is negative 5 to the power of 0. My first term, 1 less. My second term, 1 more. My first term, 1 less. My second term, 1 more. My first term, 1 less. My second term, 1 more. So negative 5 to the power of 0 is still 1. Times 1 is still 1. 4z to the power of 3 is still 64z to the third. So that gives me 64z to the third. Negative 5 to the power of 1 is negative 5. Times 3 is negative 15. 4z squared is going to be 16z squared. So 16 times negative 15 is going to give me negative 240z squared. Negative 5 to the power of 2 is 25. Times 3 is 75. 4z to the power of 1 is 4z. So 25 times 4z is going to be 300. No, sorry, 75 times 4z is going to be 300. Z. Negative 5 to the power of 3 is negative 125. 4z to the power of 0 is 1. So negative 125 times 1 is negative 125. Times 1 is negative 125. So that's what happens when you got a negative in there. It's going to come out when you do your exponents. I hope that was clear, and we could go farther, but the larger the numbers, the more that I'm going to want to use a calculator, so that's why I'm not going to show them, okay? But I hope you understand.